Okay, please scan your QR code for today. Right, while we wait for others to join. Okay. You guys doing today? Okay, looking at the names who attend. Who are here today with me, thank you very much for spending your time. Okay, anyone who has joined can scan the QR code. Please, remember that at least minimum 2 times per week, you have to scan this QR code to show your participation commitment for a week for this course. So regardless how you assess the notes, okay, through the video, through the slides, through the lecture, through the OneNote class, notebook, and so on. So just, or either you do your work, you do your exercise, whatever ways that you assess, you participate in this course, you just scan the QR code. So minimum 2 times per week. So if you can scan it more than 2 times, is better. It's good for you because it reflects how much you participate in this course, which is important for me to record it. Okay, all right. And just for you guys to know that we're gonna have tests this week, next week, sorry. And I'm not really sure when exactly the date. We try to make it Wednesday to Friday, like that. And this Friday, we're going to have a quiz, a short quiz, a simple quiz, just to make sure that every one of you can join in and can participate in that online quiz, because we need to, to be ready for the test next week. So the quiz is just actually to test our approach. Is it okay, and is it you have a problem or not to sit for the quiz. Okay, because we have to ensure that before we conduct the test next week. Okay, all right. Hopefully everyone is clear about that. Okay, so maybe we can start. Okay. Okay, all right. So we're gonna continue to our lecture. May I know where, I think, kejap. Okay. Okay, may I know where did we stop last time for your group? I think it's this slide, is it? If I'm not mistaken, am I right? Can anyone correct me if I'm wrong? Anyone? Friction loss. Oh, okay, we already friction loss. Oh, okay. So, okay, friction loss means that we start with friction loss. Is it? This slide. Am I correct?
Yes,
Can
madam.
anyone verify, please, as well?
Yes, madam.
Okay. All right. Yeah. Okay. Thank you very much, Azwan, for responding. Really appreciate that. Okay. So we're gonna continue our lecture. Which last time we stopped at elastic shortening. Okay. Sorry about a bit lost there because your group that is kind of like start with 2 hours and then having 1 hour later, because the other two group is start with 1 hour, so then we continue with 2 hours. So normally I finish this pre-stress loss slide within 2 hours. So for your group, you kind of like stop in the middle of the lecture, because you have 2 hours first and then the remaining 1 hour where I get to finish the slide. Okay. All right, so we're going to continue. Bismillahirrahmanirrahim. Okay. All right, so friction, yeah. So we go to the second immediate, we call immediate pre-stress loss, which is friction. Okay, for friction, we call frictional loss, all right? So for friction, why there is a friction? Friction exists due to the, when we have post tension. When we have post tension, then we have the, what we call as a duct, and also sheath or sheath where we place the tendon inside the beam. Okay, we have to have the duct because we do the concreting first before we pre-stress the tendon. Okay, so the reason why what we call that, because of the, if you can recall our tendon profile before. Okay, we have two condition of the cable, right? So the cable can be straight line, means linear. Okay, it's a straight line cable, or it could also be parabolic cable, right? Means that it has like a curve area, a curve behavior. So when you have that, especially in a post tension member or beam, so basically your duct also will behave like that. Means if say that the tendon is a straight line, so then your duct also straight. So when if your tendon is a curved tendon or parabolic tendon, so then your ducts also will be curved. So when you apply your force, okay, when you want to pre-stress, you want to pull your tendon, so basically, it's not really an issue if it's a linear. Okay, there will be an effect, of course, because there will be a gap inside the duct. So the interaction between the tendon and the duct's wall, we kind of like when you pull, there will be like something touching, something like a friction where because there are something that holding the movement. Okay, that is when the cable is linear. But when the cable is curved, so then the loss will be more. All right, because the tendency of the tendon when it's being pulled, it will try to be straighten itself. Then in a way that is very difficult, and then because of the curve, position of the tendon, so then there will be a loss of friction or interaction between the tendon and also the duct wall or the sheath wall. Okay, so that's why when it tries so hard to, because logically what you get is when you pull 1000, you will feel the 1000 kilonewton at the end. But since that there is a friction, there is a loss in terms of pre-stress loss, stress loss when you try to pull because of the curvy shape of the tendon. So when you apply 1000, you will not feel the 1000 kilonewton at the end, because the rest of the some of the stresses or some of the forces is already lost in along the length due to the friction that is trying to hold to itself, because of the interaction. Okay, that's more or less what I can explain about what is friction loss in in tandem. So if the, say here, if the profile cable is linear, as we say, we have two conditions. The loss will be due to strengthening or stretching of cable, which is, we can call it as wobble effect. You can Google wobble effect, and then you can get so many like interesting images of it. Okay, so if the profile is curved, there will be loss in stress due to friction between tendon and also duct, or between the tendon themselves. Okay, all right, so that's what happened. So we have, so this is an example of where we have like a curved tendon along the length of the beam. Okay, so you see that the tendon is curved like this. So as what you see here is the duct bed generally. Okay, and then where this is all the cable inside. All right, so friction generated due to curvature of tendon and vertical component of the pre-stressing. So here, according to the, what we call that, BSEN code, all right, the friction will tend to resist this movement, so hence reducing the effective pre-stress force at position remote from the jacking point. Okay, so this is what I explained before. Okay, first we look at straight tendon, okay, linear tendon, which is not parabolic. So in the case of linear or also straight, so generally we can use this equation. All right, so you have px, which is cable force at distance x from jack, and then we have p naught, which is a jack force, and the e here is not eccentricity, it's actually based on Neperian logs, which is you can take the value as 2.78, 2.718. And you could use the K value in a range of between 0.005 to 0.001 radians per minute. Okay. Sorry, radians per meter, not minute. And then you have mu, which is the coefficient friction. So where to get the mu is where you refer to table 5.1. So in a way, when you refer to table 5.1, what you will look at is actually the type of the tendon that you use. All right, okay, then you will have like, okay, either it's an internal tendon, okay, either it's an internal tendon or it's an external unbonded tendon. Okay, so if it's for internal tendon, you can just simply take the value of your friction coefficient, friction. If say that it's for external unbonded tendon, so you will have like this condition, where you have to choose what kind of duct that you are using. Is it steel duct? Is it high density polyethylene duct? Is it a duct lubricated or not? Okay, as we know, lubrication, when you grease or you lubricate your tendon, okay, actually any lubricants you can use, it will reduce the friction. Okay, so that's why when you choose your coefficient of friction, it's very important, to identify it as well. Either your tendon is lubricated or not. Okay, and then because if it is, then the value of your coefficient will be differ from the non-lubricated one. Okay, non-lubricated of course will be higher than the what you call that, than the lubricated one. Okay, all right. So here, that's the first condition, whereby when the duct or when the tendon is linear, it's a straight line. So if the duct is curvature, so it means there's a hyperbolic. Okay, so of course it will experience greater pre-stress losses compared to the straight line. But the one of the obvious difference will be the existence of the theta, which is the angular displacement over distance x. Okay, the theta that for the position of the tendon. Okay, so in a way, in accordance to the code, loss due to friction can be estimated from this. Okay, you can use this equation as well, where your theta is the angular displacement, your k, and also your x is what is stated here. So if you look into the example, this example show you how to calculate the loss due to friction. So in this example, they gave you three condition of cable. So you have cable 1, you have cable 2, and also you have cable 3. Okay, so cable 1 is parabolic with eccentricity of 50 mm above the centroid at the support and 50 mm below the center of span. Okay, cable 2 is also parabolic, so you have two parabolic, but with zero eccentricity at support and 50 mm below the center of at the center of span. So, and cable 3 is straight with uniform eccentricity of 50 mm below neutral axis. So you have a different position there, and position and eccentricity different, you know, and at the what we call that at the center span also different. Okay, so if the cables are tension from one end only, it's because one reason because it's a push tension. Estimate the percentage loss of stress in each cable due to friction. Okay, assume K is equal to 0.005 per meter. Given the equation of parabolic cables is Y is equal to 4E over L square multiplied with XL minus X square. So if you look here, this is the diagram of how the cable looks like, because we have three cables, cable 1, cable 2, cable 3. This is all the cross section at end span and also at the mid span, where the position of the cable is different, the centricity is different. Okay, you can check back with the question later on yourself. All right, so I just want to show you how to how you know in quickly how they calculate this. So calculating by considering one by one, cable 1, cable 2, and also cable 3. Okay, so you take the mu, right, by internal strength from table 5. So you can decide what type of material you use and so on. Slope at the ends at x is equal to 0, right, which is you get the slope is equal to 4e over L. Then you can calculate it and you can get the theta is actually 0.008 radians. Okay, right. So here between tangent, you consider tangents, and here we have like cable 2. Okay, so the difference will be the value of the slope at the end, right? Because you have a different E here. Okay, so then it gives you a different theta as well. Okay, so the initial pre-stressing in each cable is where you're gonna get like 1200 for the force, multiplied with 200 is the area of the tendon, then the force initial is around 240. Okay, so cable 3, where your theta, there's no slope because it's a straight line, then you have this equation where at anchorage of x is equal to 10 meter. Okay, then loss for each of the cable you can calculate one by one. Calculate cable 1 by putting all the values of your E or K, and then you have the loss for cable 2 and also loss for cable 3. Okay, so each of the cable will have their own loss. Then if you want to total, then you will total each contribution from each cable. Okay, do I get myself clear? Right, Fatim Nadia, are you clear? Okay. Okay. All right. So next we'll go for anchorage slip. Okay. So friction loss and anchorage slip is only experienced by post-tensioning system, not by pre-tensioning system. Okay, right, because of the method, the pre-stressing method is happen or is conduct after concreting. So then these losses will be considered for post-tensioning. So in most post-tensioning system, when the tendon force is transferred from the jack to the anchoring ends, the friction wedges slip over a small distance. Okay, the what we call the behavior is very simple actually to understand, because if you have something, they're very tight, like a bolt screw and so on, and then you have like a bar, and then you try to pull the bar. Okay, you try to pull the bar, what will happen? The connection that gripping the bar is trying to hold the bar from moving. But in a way, when the force is so big, you know, is so strong, it will somehow rather able to move the tendon, the bar. Okay, and what will happen to the one who gripping the bar? So the grip, the system that gripping the bar will also move. You know, there will be like some kind of movement, because it letting the bar, like, you know, going towards the force slowly, or, you know, gradually. Okay, so that's the thing. So anchorage is something that gripping the tendon. Okay, and we have the wedges, is like a washer between the tendon and also the anchorage, right? So anchorage also move before it settles on concrete. So loss of pre-stress is due to the consequent reduction in the length of the tendon. Okay, we consider that the loss is due to when the length is shortened, then we consider there is a loss of pre-stress there. Certain quantity of pre-stress is released due to this flip of wire through anchorage. Okay, so this is what we're talking about before. All right, if you look into this picture, all right, so here is what we call as the anchor block. Okay, this is actually the one who holding the tendon here. Okay, if you can see the, I don't know why I cannot take the one. Okay, if you can see this one, this the like a ring at the picture there. I cannot enlarge it anymore. This is the largest that I can show. Okay, this is the wedge. Wedge is actually looks like, I can say that it is like the what we call the function is like washer. You know, washer, like a ring, right? Like a ring in between bolts and nuts. Normally in between bolts and nuts we have the washer. Why we have washer is to reduce the friction. Okay, the friction between, direct friction between the bolts and also the nut. That's why we have washer. Okay, so the same thing here. So the washer is actually holding, you know, between the ankle grip and also the tendon movement. You know, when the tendon trying to move because of when you pull with the jack. Okay, so the amount, okay, so amount of slip depends on type of wedge and stress in the wire. So the magnitude of slip can be known from the test or from the pattern of the anchorage system. So loss of stress is caused by definite total amount of shortening. I think we talked about that before. So percentage loss is higher for shorter member. Okay, this is something that, you know, when you have shorter member, then you have more loss. Okay, because of the concentration of the force applied. So due to the setting of anchorage block, as the tendon shorten, there develops a reverse friction. Okay, because of the anchorage. All right, so let's see how the loss is, you know, we consider in anchorage. In most post-tensioning system, when the cable is tensioned and the jack is released to transfer pre-stress to concrete, the friction wedges employed to grip wires slip over a small distance before the wire are firmly housed between the wedges. Okay, so there will be a movement. The movement that cause the loss, friction loss, sorry, not friction, the anchorage loss happen. Okay, so the magnitude of slip depends upon the type of wedge and the stress in the wire that we apply. Okay, so wedges is like washer as well. There are so many type of you know, of the washer. So of the wedge. So every wedge will give you, will able to contribute different ways. Okay, so they're able to reduce the loss. Okay, so the magnitude of loss stress due to slip can be computed as this. All right, as we say that the stress is represented by the shortening, that's why we have it as a delta. All right. So when you have here, P over A is actually represent the stress, and then you have delta over L. This is actually represent the strain. Okay, so basically you are calculating the stress, So in general, we consider the delta, which is it represent how much losses that the will experience. Okay. All right. So here, Anchorage loss can be accounted for the site by overextending the tendon during pre-stressing operation by the amount of draw in before anchoring. Okay, so loss of pre-stress due to slip can be calculated. Right. Okay. Uh, where you have a slip of anchor. So this is a simplified, I mean, from the equation, it's the same one actually. All right. A concrete beam is post tension by a cable carrying an initial stress of, let's take a look at the example, shall we? So initial stress of 1000 Newton per m square, all right, and the slip is around like 5 mm, the modulus is around 210 or steel, okay, talking about. Okay, so we want to see what's the effect to the long beam and shorter beam. So we have long beam about 30 meter and the shorter beam about 3 meter. Okay, so loss of stress. So it's a very straightforward calculation whereby you just apply this equation, and then we know that what we call that uh, the strain given here. Okay, is around like a 5 mm. See the slip. It gives you direct. What would be the slip? The shortened part, which is 5 mm. The slip is 5 mm. Okay, and then multiply with the E, then directly you get how much is the loss. Okay, once you actually, it will really depends on what will be the distance of the slip. Okay, you measure the distance of the slip, then you directly gonna get able to get what will be the loss of the stress. Okay, then you get to 3.5%, and here you get 35%. So it kind of like proof that when it being a shorter length, of the beam, then your loss in your anchor will be bigger. Okay, regardless, it's the same, what you call that, the same slip, like a 5 mm, it's still the same. It's just, when your length is shorter, then your beam will experience more loss in terms of anchorage. Okay, all right, am I clear? Everyone can follow? uh okay, Asan, okay? Ahmad Asan, Izam, Inshira,
Okay, madam.
Mirza, okay, I hope everyone is okay. Yeah? Okay. Okay, I didn't manage to upload yet your slide. Inshallah, by today I will upload all the recorded video. But one thing I noticed, sometimes there are some of the videos is not like, smoothly recorded. I don't know why. Maybe because of the connection or something like that. Okay. There are some video that didn't record earlier in the beginning. It's only started later and so on. I'm not sure why. I just noticed that a few times. So if say that you didn't, please don't, please take the opportunity to also, watch other classes video as well. Okay, don't just watch your class recorded video. Okay, please take an opportunity because I uploaded every video in the YouTube for every class, so you can rewatch there anytime you want. Okay, you even can download it if you want. So what we call that, so you can rewatch other video from other class as well. Okay, I didn't know, I didn't realize that when you press recorded, it's only recorded after certain minute. It's not recorded earlier. It's not like immediately will record the lecture. Okay, so yeah. All right. So we continue with, we finish, yeah, with immediate losses. Means that losses that happen immediately. All right. Immediately is either right after concreting or right after your pre-stress. Okay, you pre-stress the tendon. So that's what we call as immediate. Means you can see the effect of the losses immediately. Okay, so next we go time dependent. So time, when we say time dependent, it actually more to during the service stage. Okay, so because through time only then the beam will experience all these losses. So when talking about time dependent, the losses is actually has so much to do with the material behavior itself. All right, which is we have two main material that we use for our pre-stress beam, which is one is concrete and another one will be steel. Okay, so these two material will, you know, will experience losses because of its own, you know, criteria, their own, you know, properties and so on. Okay, so when for, so it will somehow rather affect pre-stress beam behavior as well. Okay, but then it's more time dependent. Mean it's not happen immediately, but through time you will see, you know, the material will degrade, you know, will experience, you know, losses, and then it's all due to, you know, because of the material properties itself. Okay, the how it performs. Okay, one will be creep. I think I'm sure everyone familiar with concrete creep. Okay, and we know that creep is not going to happen overnight. Okay, creep is always happen like through time. You can only see like maybe in 5 years or 10 years or something like that. You know, you can see the degradation of the concrete itself, all because due to the quality of the concrete material. You know, it might because of the age, it might because of, you know, the stress that you apply, the density of the material itself, the cement content, you know, the grade of the cement, you know, the quality of the cement, the water cement ratio, is it high, is it too dry, and so on. Humidity and temperature, which is excuse me, talking too much now. Relative humidity and temperature, which is, this is related with, you know, the ambient of where you place the pre-stress beam. Okay, all right. Okay, so creep is due to, for pre-stress we say that creep is due to permanent loss only, where we try to estimate what is creep loss. So temporary loss are not considered. Since the pre-stress vary along the length of the beam, an average value of pre-stress is considered. So changes due to creep, which is related to instantaneous pre-stress. To consider this interaction, the calculation of creep can be iterated over small time steps. Okay. All right. So in this case, what we kind of like estimate is actually we consider the use of the creep coefficient. I think we used this before. You guys used this before. Come across this value when you guys, I think if I'm not mistaken, in your RC design, when you design for your slender column, if I'm not mistaken. Okay, because there was one of you guys asking me about this, and then I just remembered, oh, okay, it's the same. Okay, here is whereby you see that the specific creep strength, okay, times with this value. So this is basically what you can, this, when you have your creep coefficient is where you will be able to calculate what is the creep strength. Right, the creep strength is actually the one that you're gonna use in terms of calculating what will be the total stress loss. Okay, the total stress loss mean what is the loss of it. Okay, then you'll be able to calculate the loss. Okay, so let's take a look at the examples here. So it's a very straightforward examples. Okay, if you look here, so here is where you have 100 mm times 200. Okay, you have the E50, the area cable. Okay, the final stress. What will be the ultimate creep strain? okay, this one of stress, and the E, okay. And what you do is you just use this equation to get what is your what you call your stress, okay. And this is where you calculate your force tendon. This is kilonewton, okay. The tendon force by considering the area of the cable. So multiply with the stress of the cable, then you get what is the force. And this is the initial moment initial, okay. Second moment of inertia. Then you have this at the support section where E, then you get the stress. Okay, what will be the stress? Okay, the loss, 8 Newton mm. So once you get the 8, this is the value, the stress CP. So then you will calculate at E 50 mm. Just now you calculate for E at 0. Here is E at 50, then you get here 10.7. So the average is around 9.3 for both conditions, because as we say, we want it throughout the length. So we just take average value of your stress. Okay, so once you get your 9.3 of your stress, then you multiply with specific creep strain, which is given here in the question, plus with times with the modulus E, then you will get around this. This is the total stress. Okay, the important is actually the average stress that you calculate for each condition of your E. Okay, so then the loss, the percentage of the loss divided by the what is the initial stress applied, multiply with 100, then you get around 4.9% for the creep loss. Okay, all right. So hope you guys are clear about that. So next we go for shrinkage. For shrinkage is actually when you have, normally for concrete, when you have creep, you're always gonna have shrinkage as well. Okay, it's like a good pairing, something. Okay, so time dependent strain measured in an unload or an unrestrained specimen at constant temperature. So the factors responsible for creep concrete will have influence on shrinkage of concrete, also except the loading condition. Okay, so in this case, due to shrinkage of concrete, shrinkage to be considered depends upon the following. So it's the same as what you have for your what you call for your creep. It all depends on the materials quality, which is what type of aggregate used, you know, the water content, the age at transfer effective, is it too early or too late or something like that, effective section thickness, you know, and what will be the ambient condition, the humidity, the temperature, and so on. Okay, so for shrinkage, humidity is very one of the important factor to be considered when you when you want to calculate shrinkage. So for this given here, because this example or this note is taken from most Libani book, which is the main reference is from the S. And with or we have like what we call that with UK annexes. So that's why the value of 80% relative humidity, 50% for it is all based on UK, temperature data, okay, taken from UK data, okay. So the loss in still stress is given as if for Malaysia, then you just, it's simple, just go to Malaysian annex. Then you will get the data for our country, okay. So the loss in still stress is given by this, which is strain CS multiplied with modulus, and then you have the, the force, because this is already the stress, you multiply with the area, then you get will be the force, okay, of this thing. Okay, so here, when you have, because somehow rather, since because of like the tendon is inside, is placed inside the concrete, that's why when any movement of the concrete, it will kind of like affect the tendon directly. So the losses, even though the concrete which experience the shrinkage, but somehow rather it will affect the tendon. Okay, a concrete is prestressed by cable carrying initial prestress force of 300 kilonewton. So the cross-sectional area is 300 mm square. calculate the percentage loss of stress in cable due to shrinkage for the pre-tension beam. So assume ES 210 kilonewton per mm square and total residual shrinkage strain is about 300 times 10 power of minus 6. So this is the important value actually. Okay, the total residual shrinkage is where you're gonna use. Then that somehow this is gonna place here where it will give you what will be your value for your loss of stress. Okay, right. So when you calculate, you divide with the initial stress, then you will get around 6.3%. Okay. So if you notice in terms of pre-stress loss, the calculation is very straightforward. So you calculating the loss depends on what will be the value of each parameter that caused the loss. Okay. Lastly will be still relaxation. So I don't want to talk much about this. Basically, it is, I think we talked about how steel behave before. Okay, where it goes linear, it go plastic, it go hardening, and then it will fail. Right, so when you go elastic, then when you let it go, it will go back to its original. So when it pass through plastic, when you let it go, then it will not go back to its original. So means that you have, when you go back, it will go back somewhere here. So then you have some stress losses experienced by the steel. Okay, so in a way, we say that decrease in the stress is due to the fact that some of the initial elastic strain is transformed in inelastic strain under constant strain. So means different strain is applied. So stress decrease according to the remaining elastic strain. So it's decreased, the stress. So there's a gap. So factors affecting relaxation, we have time, initial stress, temperature, and also the type of the steel. Okay, so all this will affect because we're talking about steel. So it also, of course, the properties of it is matters, yeah, because like composition of the manganese, composition of carbon, iron, and so on. Okay, and also what will be the initial stress applied. So in Eurocode, for using 1000 hour relaxation, we can say that the loss of relaxation still is about 70% of its characteristic strength. So if say that characteristic strength is 270 MPa, so the loss due to relaxation is around 0.7 times 270 MPa or 500 MPa. Okay, so losses about 4 to 10% of pre-stress force after transfer. So you can consider for the pre-stress force losses is about 4 to 10% after transfer. So this is what we can conclude for relaxation of steel. So when you calculate loss due to the time dependent, you can include all. Okay, means that you include all creep, shrinkage, and also relaxation. So when you combine all equation, then you will get that, in terms of this equation. Okay, so this is the acronym of the abbreviation. Okay, so here I already released you an assignment, okay, for you to go through. So I want you to redo back this example. Okay, this example is actually taken from mostly Bangi book. Okay, it's not like something different and so on. But try to redo it and then just hand it back to me in your OneNote just for me to see, because just want you to go through this example yourself. All right, so try to go through and then just putting the, what we call that, all the equation, using the equation by putting the parameter given in the question. Okay, so please redo this and then and then just attach it in your OneNote so that I will take note lah, whoever has do it or not. Okay, so and then the next slide you can see this is just an example for you to know when you have to estimate eccentricity of the tendon. Okay, I placed the example this slide actually earlier before in the beginning of the slide, so I just put it at the back because I think maybe I put it at the back as another example towards the end. Okay, so you can relook lah the example try to recall, and then how it will affect the what we call the calculation of the elastic losses. Okay, any questions, soalan? Any questions, soalan, before we end? Farahida, any question?
Yes, madam.
Shaza?
Madam?
Sorry, I cannot hear you. Can you type something in the chat? After the class, I will figure out what's wrong with my with my speaker. I don't know, I cannot hear. Amirul Ashraf, you okay? Shaza, Said Shahrul? Understand? Fatiha? Shafiq? Okay. All right. So I hope you guys can, according to the test next week, do we have to derive equation? Okay, to be honest, I don't know how the test question will be. It's not me who set the question, so I didn't get a chance to look at it yet. So I really have no idea how the question will be. Okay, but to me, like I said, like I always say before, okay, especially during this online learning, right? So just make sure that, because this is your own learning, you know, just make sure you understand it properly. For example, like the equation, I say it again and again, you need to understand how to derive the equation. Okay, it's not just about you know, for you to be able to answer question in the exam or so on. No, it's actually it's important for you to be able to derive, because it kind of like reflect either you understand or not the equation, right? So that's why it's important. Okay, so because at this point when you do online learning, it's not really much about what question will be, you know, be asked in the test, because the test all will be online. So I'm sure it will be, you know, not as hard as when you do final exam, not as stressful as you do final exam. Okay, and I believe that, you know, if you try your best to understand and really know how to do it, okay, especially, you know, things that we have learned, I'm sure you wouldn't you know, will not have any problem with it. Okay, and then your test is only gonna include until you're gonna cover it until our last week lecture, Magna diagram. So you have only, like, you know, two possibilities of calculation that you might need to really understand. You need to understand how to do Magna diagram, and also the pre-stress the pre-stress force, and how to do the stress force, of course, and then the stress limit. Okay, how to calculate the stress, you know, the top stress, bottom stress, you know, transfer at service and so on. Okay, you need to understand that equation and then be able to answer the question given. Okay, so inshallah, I think you guys will be okay. You'll be all right. I mean, the important thing is just to make sure that you guys understand the topic. Okay, and I'm sure the question will only test your understanding. Okay, so if you understand well, shouldn't be a problem for you to do. Okay. All right. Any other question? Thank you, Farahida, for asking. Anyone else? Is there any other question? Salsabila? Okay. Faris Helmi? Muhammad Faris Helmi Zan. Okay. All right. So I think if there is no question, oh sorry, is there quiz esok include dalam carry mark ke? Hard to ask. Sorry, hard to answer that. I'm not really sure yet because I've been told it's only to test run the system to get ready for your test. But the question, no need to worry much about the question because the question is very straightforward. I think I'm sure you guys can answer that. There shouldn't be an issue, but just for, like I said before, you learn and then you just try and do your best. Okay, regardless is included the marks or not. So because it's hard to say because I think the quiz is 10%, right? It's not me who set the question. So what I've been told, we're gonna be a quiz, so I'm not sure either it will be included or not. So what I can advise is you just do your best. Okay, if you do your best, inshallah, you know, regardless what, you will get hikmah from it. Okay. All right. Any other question? I'm sorry I cannot answer it directly because honestly I didn't know. I don't know either is included. If I know, I'm sure I will tell you directly. Okay, Shafiq, okay. All right. Nizam, Zaim. Okay. I hope you guys stay safe. Tomorrow is already Ramadan, right? Allahu Akbar. Okay, tomorrow is already Ramadan, and then it's very, you know, Madam quiz tu ada masa ke? Ada. Quiz tu ada masa. We set the time. Okay, of course we have to set the time. For quiz and test, we have to set the time. If not, it will become like your assessment, regular assessment. It's like you are doing an assignment without the time limit. Okay. All right. So, okay, I think that's all. Anyone else? Okay, so I think if now, I think I end the lecture for today. So, okay, selamat menyambut Ramadan to all. Okay, stay safe, right? Be at home, you know, please really, what we call, make use of your time. I know everyone is busy with the lecture and so on, but please also spare some time, you know, spend it with your family, help your parents, you know, with anything, you know, especially during Ramadan, you know, and all. So it's a privilege, actually. It's a hikmah. It's a great hikmah, being able to be at home the whole Ramadan, you know, and you know, somehow like, you know, beribadah for during this session, kan? Okay. Madam, quiz esok pukul berapa? I'm not sure yet. I think pukul, FM ada masa, but I'm not sure pukul berapa. I will get to you back by today, insyaAllah, because the coordinator didn't tell me anything about it yet. Okay, if anything, I will update you guys through WhatsApp. All right. Latest by tonight we should know already what time tomorrow. Okay. All right. So I think that's all. Any else? Test daripada Wednesday to Friday, which means 3 days, or kita pilih mana-mana hari. Okay. All right. To tell you the truth, okay. To tell you the truth, actually that is what we want to do. Sebenarnya we want to fix the duration of the test 2 hours, but student can choose any days that you want to do. All right, you can, because it will be like from Wednesday to Friday. So supposedly student can choose any time that they feel ready to take, you can take. But we are not sure either we can implement it like that or not yet, because it will depends on your quiz tomorrow. Okay, because you guys also have to understand, this is also a new situation for us. Okay, so we have to do some trial and error. All right, so that's why we do the quiz first, just to see either how can we the best way to implement your test next week. Okay, do you get me? Okay, we'll see. All right, thank you. Anything else? Dah 3 kali cakap nak end, tak end ni. All right. Okay, thank you very much. And so I end the session with Assalamualaikum warahmatullah. Okay, everyone take care, stay safe, and selamat berpuasa to all, okay? All right. Take care, everyone. Assalamualaikum warahmatullah. Thank you. Selamat berpuasa.